In 10.3, we're going to look at determinants, identities, and inverses, and all these are going to still deal with matrices. And some of this we'll do on calculator, some of it we'll do by hand. So if you don't have your own graphic calculator, go ahead and borrow one from me now. Every square matrix, M by M, has a number associated with it called a determinant. And to have a determinant, it again has to be a square matrix. A square matrix is just like a square in general. We think geometry, we think of square. If this side's 2, this side has to be 2. With a matrix, it's kind of the same idea. M by M would imply however many rows there are, you have to have that many columns as well. So if there are 4 rows, it would have to have 4 columns. And if it's not a square matrix, it's not going to have a determinant. Determinants can be represented either with the abbreviation DET, or normally around our matrices we use brackets. If you see vertical bars, like on example 1 part B, that tells you you're taking the determinant. And to do this, we're going to use our calculators. So for example 1, go to your graphing calculator out in front of you. And we're going to start this a lot like we did last time when we learned how to multiply on here. We'll make sure it's turned on. And your first step is going to be to take matrix A, the 0, 4, 3, negative 1, and get that into your calculator. So if you go second inverse, that'll get you the matrix. And then yours may have some things in there. Either way, we want to go edit, hit enter, and we need to tell the calculator what dimensions we have. So look at the one we've got. What dimensions would that be? 2 by 2 is right, so we're going to enter that in. And then the calculator will reset the size. We're going to start putting our entries in. So 0, enter, 4, enter, 3, enter, negative 1, and do not forget to hit enter after that last entry. Once that's in, we're going to quit by second mode. We should be back to our home screen. Like what we did when we multiply, we're going to go back to our matrix menu. We did names and we did edit. Now we're going to go to math. And look at our first option there, DET. And what did we already say that stood for? Determinant. So hit enter and tell it that you want to take the determinant of matrix A. So go back to matrix, click A, hit enter there, close your parentheses, hit enter, and there's our answer. The determinant of the matrix A, which was 0, 4, 3, negative 1, is negative 12. For the next one, we've got those vertical bars. And what do those tell us we're going to take? The determinant. So we're going to go back to our calculator, go back to matrix, and I'm going to edit matrix A. What dimensions does this one have? 3 by 3 is right. So 3 by 3. It resets it. We type everything 1, 7, 11, negative 4, 2, 8, 14, negative 3, and 1. Enter. Before I back out, since this one has so many entries, I'm going to make sure that I got it right. So I'm going to recheck, and I got 1, 7, 11, that's good. Negative 4, 2, 8, that's good. 14, negative 3, 1, that's good. So I would recommend you double check them just to make sure you don't mistype something, because one number's off, throws the whole thing off. Second quit, go back to matrix. You remember where we went from here? Go to math, and then choose the first option, DET for determinant, and tell it we want to do it for the one that we just put in, which is matrix A. Hit enter, and we get 662. So that's our answer there. We'll come up with, as we move through this chapter, some uses for the determinant, but for right now, I just need you to be able to figure out what it is. One of our other points today is going to be something called the identity matrix. In mathematics, identities are something that you've learned to work with a lot. Like in addition, 0 is the identity number. You can add it to something and it won't change. For multiplication, 1 is the identity number. You can multiply by 1, it doesn't change it. The identity matrix kind of does the same thing. If you multiply a matrix by the identity matrix, it doesn't change it. These will always look like a square matrix, so either like a 2 by 2, a 3 by 3, a 4 by 4, so on, with a diagonal of 1s. So let's notice how it's all 1s across there. On the 3 by 3, it's all 1s across there, and all the other elements are 0. So everything other than those 1s are 0. One way you can think about it, whatever's in the same row, same column kind of thing has to be a 1. Like this one was row 1, column 1, it's a 1. When I'm in row 2, column 2, it's also a 1. Same deal over here, but I also have a row 3, column 3, and then everything else ends up being 0. Let's turn it over. Two matrices are inverses if their product is an identity matrix. So when you multiply them, you get the identity matrix. And if they're inverses, that's like addition or subtraction. It undoes each other. It's like division or multiplication. They undo each other. Like a square root and a square undoes each other. For a matrix to have an inverse, its determinant must be some number other than 0. So when you're asked, is this going to have an inverse? Just do like what we did on example 1. Find the determinant. As long as your answer is not 0, then yes, it's got one. If it's anything else, no, it does not. So example 2 is going to ask us just that. State if an inverse would exist for each matrix. So in other words, we are going to find the determinant. So get your calculator back out. We're going to do this just like we did on example 1. So I'm going to go back to matrix. I'm going to edit the first one. Now it's a 2 by 2. And I'm going to make it 3, 2, 6, 4. Make sure you hit enter. Quit out. Go back to matrix. Go back to math. Choose determinant and tell it to use the one that we just put in, which was matrix A. Hit enter, and we got 0. So the determinant was equal to 0. That means that no, there is no inverse. If you get 0, that's the case where it does not have an inverse. Try the other. So matrix, go to edit. Now we want to make it a 3 by 3. Punch it in 8, 12, 15, -1, 5, 4, 7, -2, -9, enter. Double check it. Got 8, 12, 15, -1, 5, 4, 7, -12, -. All right, looks good. Back out. Do the same stuff we just did. Go to matrix, math, determinant, tell it matrix, the one we just used, which was A, close it, enter. I get -563. So would that have an inverse? Yes. The reason why it's yes, we didn't get 0. We got something other than 0. I don't really care what it is, as long as it's not 0. It's a yes. Our last example, example 3, we're actually going to find the inverse of each matrix if it exists. So what I would recommend you do first is what we've just done. So for part A, go to matrix, edit, make it a 2 by 2, and then type stuff in. We got 3, 1, 4, 2. Quit out, go to matrix, math, determinant, tell it to use the one that we just made. So we got 2. So does this have an inverse? Yes, because we didn't get 0. Now that we've already got it typed in, we can find the inverse really quickly. If we go let's say I'm going to call this matrix A. A inverse can be written like that. That little -1. We've actually been pressing that button all along because that's what we have to hit to get to the matrix menu. So go to matrix, choose A, so just hit enter. You should see A on your screen with the cursor flashing behind it. Now just hit that matrix button, but don't press sec. Just hit the X with a little -1 as the exponent. And that'll read now A inverse. Hit enter, and there's our answer. And our answer is going to be a matrix of the same size as what we started with. So it is 1, -0.5, -2, +1.5. The way that we can check our answer is we could take the answer we just got and multiply it by matrix A. And notice what we got. We've got a diagonal of 1s going across, and then we've got zeros in the other spots. So this would be an identity matrix. And if we go back up to our definition of inverses, look what we said. Two matrices are inverses if their products is an identity matrix. That is very easy to check, and I want you to do that every time you do this. So after you get your answer, just hit times, choose the one you had typed in already, hit enter, make sure you see that identity matrix. If not, check your work, you probably just typed something in wrong. Last one, same process, but we're going to do matrix B over here. So we got to put it in, go matrix, edit, and then I'm going to make it a 3 by 3. Type in 8, 12, 15, -1, 5, 4, 7, -2, -9. Double check it. I got 8, 12, 15, -1, 5, 4, 7, -2, -9. Looks good. Quit out. I'm going to go ahead and clear all that junk out of there. Doesn't really matter, but it bugs me. Go back to matrix. Pick the one we got, so A again. And then inverse, hit that key. Hit enter. And that should be our answer. Now we're going to notice we've got a bunch of decimals, so we're going to have to round these. If you need to round, let's try to go with nearest hundredth. So A inverse would equal, I got 0.065, so I'd go 0.07. Underneath it, I've got -0.033, so I'm going to go 0.03. Underneath that, I got 0.058, so 0.06. Now the rest of it, I can't see right now, but see how there's these dots on the right? If you hit your arrow key to the right, it'll move it over. Now it's important that you don't press any other keys at all, because a lot of times that'll kind of stick it where it is to begin with. So if that happens, just redo it and then hit the right arrow key to move it over. So now in the middle column, I've got -0.14, +3.1, -0.18. And then bounce it over to the right some more. For our last column, looks like we've got 0.05, 0.08, and 0.09. And now that we've got that, let's just check it like we've already done. Hit your times key. Should pop up with answer times. Go back to matrix. Choose the one we're working with it. Hit enter. And I like what I see, because again, we've got a diagonal of 1s. Everything else is 0, so that tells me it's identity matrix. So those that I have on the screen, this matrix and this one, are definitely inverses because their product gives me an identity. So when you're working with that, that's what you do.